Hey everyone, so today we're going to work on some variation word problems. And these are a specific type of word problems, and another way you could talk about them is just calling them proportional word problems. So you're going to see this phrasing a lot. Y varies directly with X, Y varies inversely with X, or jointly. So you're going to see a couple things here. Now, this is like, an example of this would be like, let's say you were going babysitting and every hour you made $10. So at 0 hours, you make $0. After 1 hour, you make $10. After 2 hours, you make 20. So that would be directly proportional or direct variation. So long story short, how we would write something like that is y equals k times x. And basically k represents this proportional, and you can think of it as like a slope. So like $10 in this case, $10 per x amount of hours. But you'll notice for every single one of these problems we're about to do, it's going to have this value of k. And again, that's called the constant of proportionality, kind of fancy way of saying that. So if we have inversely means we are going to divide. So it'd be y equals k divided by x. And jointly just means if it depended on multiple factors, jointly with x and w, I would say y equals k times x times w. So we would multiply those things together. Okay, so important things to think about. Directly means multiply, and so does jointly, just with multiple things. Inversely means we should be dividing by that variable. Okay, so let's take a look. So there's going to be a process for these. Sometimes it will have steps like number 1, and other times, for examples 2 through 5, we'll have to just know those steps. So I'll help you guys out here. The first thing we want to do is definitely come up with an equation. So it's not typically given to us. We are going to figure out that variation equation. So it says the pressure exerted by a liquid at a given point is proportional. So we should see this is kind of a red flag. It's going to say directly varies or is proportional. And then you get to pick all your variables here. So pressure, I'm going to pick P. Okay, is directly proportional. I'm going to put K times. And again, I'm doing that because directly proportional means it's falling into this variation equation. To the depth of the point below the surface of the liquid. So depth, I'm going to do D as a variable here. Okay, now it gives us more information, but let's just write down P equals K times D. Pressure directly varies with the depth. Okay, so the first thing it's going to ask for is that constant of proportionality. And in a general sense, we're always going to solve for K first. Okay, always solve for K first. So it gives us this info. It says if the pressure is 20, if the pressure, I said that wrong. If the pressure 20 meters below the surface, that's the depth, excuse me. If the pressure is 70 kilograms per centimeter squared, so 70 is the pressure. Okay, the first thing we're going to do is solve for K. So we divide by 20, and we get K is 7 over 2. Or you could write 3.5 is fine as well. We want to keep it exact. So if you have to round on your calculator, try to keep it as the fraction. Okay, so now we really have a new equation. We know for all of these scenarios, we have either 7 over 2, or you could say 3.5 times D. So every type of pressure situation, we know 3.5 times the depth. That's the scenario. So instead of K, you'll notice I replaced it with 3.5. And so now I'm going to figure out one more scenario. It says what pressure is exerted at 40 meters below the surface. So what pressure is exerted at 40 meters below the surface? So we just do 3.5 times 40, which is 140. And we'll throw on, this was kilograms per centimeter squared was the pressure units there. So that is the final answer. Again, we wrote an equation, we solved for K, we plugged K in, and we're going to use that for a different scenario. Okay, so let's follow those same steps for our next one. Going to get a little more exciting here. Okay, so it says let y vary directly as x. So y varies directly, K times. If you guys forget to put K in your equation, you're going to be very sad because your first step won't really make sense. So y equals K as x directly, so times x. And inversely, I'm going to put division as, or you could say with, the square of m and the square of r. Square of m would be m squared. Square of r would be r squared. That's different than square root of m, right? Square of m means m squared. So let's try to write this down before we look at other info. So I have y equals k times x divided by Inversely, whatever comes after the word inversely, both of those things are multiplied together in the denominator. So here's my formula. K times x divided by m squared r squared. Okay, so remember that's step 1, I guess you could say. Step 2, if you want to write yourself a note, we're going to solve for k. So notice it's not going to say that though. It's not going to say, oh, find the constant of proportionality. We just have to know that when we see these problems. And again, how do we know this is special? Because it says varies directly. If y is 5/3, when x is 1, m is 2, and r is 3, then find y, blah, 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 blah. So the first thing we want to do is start off with this part I'll highlight in red here. We're going to start off with this info and solve for k. So it gives us a scenario if this is a situation. So if y is equal to 5/3, so we're solving for k, it says x is 1, m is 2, and r is 3. Okay, we're going to find k first. So 5/3, this is what we're doing up here. This is equal to k over, this would be 4 times 9, which is 36. Easiest thing to do here, just cross multiply. 3k is equal to 180. So k is equal to 60. So the next step, we're going to rewrite our equation. So we could say step 3 is now the equation is y equals 60 x over m squared r squared. Okay, so at this point, again, you want to make sure k is solved for and you plug it in. So I got k is 60. All right, so now there's always another part of the situation, which this part it says, find y when x is 3, m is 1, and r is 8. Okay, so now we're going to solve for a different variable. You solve for k, and then typically we have to solve for one more variable. So this gives us y equals 180 over 64, which is the same as 45/16. So that would be a perfect answer, 45/16. Or you can get out that calculator, and this is the same thing as 2.8125. Typically, we round to 3 decimal places, so 2.813. Okay, so again, think about that process. Wrote the equation, solve for k, plug k in, and solve for a different variable. So let's do that same exact thing. We're actually going to save number 3. We're going to try out number 4 and 5 here. So if you guys want to scan down to 4 and 5, let's see what's going on. So we're talking about a steel guitar string here. Okay, it says the number of vibrations per second. So the pitch of a steel guitar string, so I'm going to call this P for pitch, varies directly, so equals k times as the square root of the tension. Okay, so square root of t, I'm just going to do. And inversely, I put division with the length of the string. So I'm just going to call that L. Okay, so again, the first thing you want to do, step 1, try to come up with that equation. P equals k times the square root of t divided by L. Or you can just draw uppercase L, capital L. Okay, so let's see what's going on here. Step 2, you guys know this, we're going to solve for k. All right, so it says if the number of vibrations per second, this whole situation here, number of vibrations per second, that's just pitch, right? So if pitch is 5, when the tension, so K is what we're solving for, tension is 225, and the length is 0.6, find the number, find pitch when the tension is this, blah, blah, blah. Okay, we know that the first thing that we have to do is solve for K. So we're going to go from here. Let's see what we get. This is 5 is equal to square root of 225 is 15. So 15K divided by 0.6. You can kind of do that same situation where we cross multiply. And we get 15K is equal to 3. So K is equal to 1/5. Or you could say 0.2. Okay, so K is equal to 1/5. Same thing as 0.2. So now you're definitely going to use your calculator for this part. So if you don't have it out, you can get it out. So the step 3 is, let's talk about our new equation. Our new equation is P equals 0.2 times the square root of T over L. And that's the equation we'll use for any other scenario. So the last scenario they give us, I'll switch colors here, is they said find P, find the number of vibrations per second, which is pitch, when the tension is 196 and the length is 0.65. Okay, so 0.2 times 14 divided by, because square root of 196 is 14, divided by 0.65. You can type this in your calculator, put parentheses around the top, and you get the pitch is 4.308, and pitch is in vibrations per second. So I'll put that unit there. K does not have units because it's a constant. So the final answer should have units, but K will not. All right, and we have one more to try out here, guys. Example 5, volume of a cylinder, a little throwback to geometry for you. And this is a fun one because we'll see the connection here of why the constant matters. So let's take a look at this one. It says the volume of a cylinder varies jointly. So I'm going to do V for volume. Varies jointly, that's K times multiple things. So it says jointly as the height, so H, and the square of the radius. So these are all multiplied together since it said jointly. So step 1, volume is equal to K times H times R squared. Okay, maybe this looks a little familiar to you. Then it says a cylinder with a radius of 5 and height of 10 has a volume of 785. Find the volume of this cylinder with more information. Okay, you guys know next step, we solve for K. With that given info right here, it tells us one situation. It says, okay, if we have a volume of 785, we don't know what K is, but we have a height of 10 and a radius of 5. So 785 is equal to K times 250. And in your calculator right now, you guys can divide 785 by 250. And you end up with 3.14. What? Guys, pi! This makes sense to us because if you guys remember the old equation we were using, it was pi r squared times h. Do you guys remember that for volume? Pi r squared times h, or sometimes we did base times height for the volume of a cylinder. And this is very exciting. I hope you're excited that you got pi. It's a rounded pi, but hey, we'll take it. So our new equation, we could just keep using 3.14 instead of using the real button for pi. So remember that last step here is plug in your constant, which is 3.14, h times r squared. And then we just have to find the volume. So find the volume of a cylinder whose height, I'm reading right here, height is 15 and radius is 10. So feel free to use your calculator there. It ends up pretty nicely at 4,710, and that would be centimeters cubed since we were talking about centimeters for volume. Okay, so that is it, guys. Last one, again, you might recognize this K value, a very famous one in geometry, a constant of pi. Comes up in a lot of our surface area and volume equations. So anyways, thanks for watching. Please let me know if you have any questions. Have a great day.